Stefan, for inviting me. I'm a bit of an imposter because I do study HIV, but I'm going to talk about AIDS. And I find HIV with 9 genes, too complicated already. So what about people and societies? We have to leave that to the sociologists. Nonetheless, we all of us so-called hard scientists think that the social sciences are easy, so we can all be pundits on it, and that's what I'm going to be. Now, first of all, there's a lot of people standing at the back, and there's a lot of free seats here. And when I was last tested, I was HIV negative, and it's not transmitted by the respiratory route. So why don't you come and find some seats? Those of you on the edge, that's okay.
No airborne transmission.
No airborne transmission yet. It mutates a lot. Okay. This session has been entitled The Big Killers, Past, Present and Future. Well, Laurie's going to speak about the future, but no one's speaking about the past. So I make no apologies for bringing up some of the big killers in the past as well. And what I want to do is really say, well, is AIDS so unusual? And what's going on with the big infectious killers of mankind? And of course, there was a past not so long ago when we had the Black Death as portrayed here. And of course, money was involved then, and the poor people didn't get it. But I wouldn't say it was a disease of poverty. It was a disease of everybody, because even the rich who had warmer clothes had plenty of fleas. But social aspects certainly were very important. And now we have HIV. These little red dots on this electron micrograph of lymphocytes are HIV. This is a virus, an intracellular parasite. It grows inside cells of the immune system, T helper lymphocytes, macrophages, possibly dendritic cells, and slowly destroys the immune system, so that the infected person, by the time they develop AIDS, on an average of about 9 or 10 years after infection, become open to all kinds of other infections. The so-called opportunistic infections and opportunistic neoplasms, cancers that develop in AIDS. But during the long incubation period before disease, the infected person is infectious much of the time. So he or she may appear healthy, but can transmit that virus sexually and parenterally if their blood can gain access to someone else's bloodstream. So, it's a long, slow disease. And if it has as short an incubation period as Yersinia pestis, as bubonic plague, which also infects the lymph glands, the buboes were the lymph glands, then we might be able to control it better. But it's these slow ones that nevertheless move that is rather difficult. Of course, tuberculosis, malaria, the other big killers we're going to speak about are similar. So, now you've seen these sort of statistics already today. I retyped the UN AIDS things because they never put everything on one table. But first of all, everyone talks about the number of people living with HIV and AIDS, which is roughly of the order of 40 million people. Let us not forget the 24, 25 million people who have already died just in the last 20 years as a result of HIV infection, essentially from AIDS. So if we add those two together, we're talking about closer to 65 million. Then of the adults infected, it's 50-50 men and women. So let's get that straight. They're little local epidemics that are mainly amongst gay men, but that doesn't impinge on the worldwide epidemic. It did impinge very largely on how we dealt with the early stages of it. And of course, they're children too. Last year, according to the UN AIDS and WHO estimates, about 5 million people became infected, and about 3 million people died. So the prevalence in the world is still increasing because infection is spreading faster than people die. So this pestilence is not going to die out that quickly. It's still gaining ground, and there's lots of new fertile ground for it to spread to. And as we've heard already, this is having some impact on populations that are most affected. So what I've superimposed here on a graph of Tony McMichael's, the black curves are life tables from mainly from this part of the world in different centuries. And you can see in the developed world, by and large, there's a very low infant mortality, and then we don't really expect to die until we get old. I've recently become very interested in life tables because I'm there, right on the edge of the precipice. But it wasn't always so, and only 8,000 years or so ago, in the Fertile Crescent, where big cities first developed, we had life tables like this, that life was nasty, brutish, and short, as people say. And it's under those conditions that humans evolved. So we haven't had much time in terms of Darwinian natural selection to catch up with being civilized. And that's why so many of the Western diseases are diseases of civilization, type 2 diabetes, cardiovascular disease, cancer, and so on, which had no selective value when you died before you were 40, but have a lot of significance there. And then we have a country like Botswana, perhaps per capita the world's richest country in AIDS due to the other kind, aid, due to AIDS. We have a curve like this with a double curve, that there is a new downward curve of mortality in young adulthood. And this is an unusual infection, HIV, that most infections kill off infants or the elderly. But if you've survived to adulthood, you expect to survive a bit longer. And HIV is picking out young adults as the major population that it's killing off. Of course, older people die. In fact, there's a much faster progression to AIDS if you're older than if you're younger. And of course, infants die as well. But it is unusual in that respect. Well, that's looking at a bit of history. What are the big killers today? Simon Wayne Hobson and I drew up a sort of Richter scale, not of mortality actually. This is roughly based on Dali's, a sort of complex of mortality, morbidity, years of potential life lost. And HIV's up there. I think only tobacco is actually above it. That's something we could prevent, tobacco-related deaths, but we don't know how to. It's again our social behavior or antisocial behavior. It's not science that tells us what to do about that. And here the other two we'll hear about. And of course, if we added HIV-TB to non-HIV-TB, it would be up there. But let's not forget hepatitis. Measles is still a major killer in many parts of the world. And down we go. Probably of all the viruses to the left, everything else to the right. I'm a virologist, so that's the only reason there are more viruses up there. If we read the papers in the United States, you might think that West Nile would be at the top there because it's received the most column inches. But then that's a local thing because rather like AIDS 20 years ago, it's new in the Americas. It hadn't crossed the Atlantic before. It's increasing. It's spreading like wildfire in wild birds, and it's transferring to humans. But there's still only a handful, a few hundred deaths. But let's not be complacent because HIV was down there a mere 20 years ago. So these things will change. We don't know which is going to be really important. And it's the next one will help me to illustrate change as well. Now here's a beautiful painting. of the Garden of Eden by a local German painter, Lucas Cranach. Of course, I'm not a creationist, I'm an evolutionist, but it serves the purpose that it's not that long ago that we lived in small populations of hunter-gatherers. And we didn't have some of the infectious diseases we have today. And in a sense, the metaphor I'd like to put is that some infections co-evolved with us. And those are what I call the family heirlooms that are handed down from generation to generation. You know, imagine this as a nice stately home or art gallery. And then there are zoonoses, temporary exhibits that we pick up from other species. We might pick them up just as one individual and then it stops. So you're bitten by a rabid dog and you get rabies. Now, if your carers make sure that when you get rabid, you don't bite them and foam at the mouth and so on, if you're restrained, you will die, but it stops there. It's no epidemic. We also, and we hope that variant CJD, little local epidemic in the UK, will be the same. We don't know whether it's going to be blood transmitted. We don't know whether it's going to be naturally transmitted. But all the evidence, both in the cows and the humans, is that it's a food-borne zoonosis and it's not transmissible from person to person. But it's early days. Then there are also zoonoses that make local epidemics, such as Lassa fever or Ebola fever, the ones that, you know, make you shudder and very nervous. And so far, none of those have become worldwide pandemics. But why not? And who knows in this global village what will happen next? But to date, the reproductive rate of these viruses in humans has been less than 1. People who've had close contact with infected people become infected at it's highly contagious, it's highly lethal, but these epidemics have petered out. And even the 1996 Kikwit outbreak of Ebola, in the middle of the communal and civil war in the so-called Democratic Republic of the Congo, and where people fled to Kinshasa and Kisangani and other cities, somehow this petered out. It didn't spread. But it might do in the future, and we don't know. Now, why do I say that? Well, I would say that these major, I've just listed viruses here again because I'm a virologist, but you know, it could be TB coming from bovine TB. It could be all sorts of other rickettsia, parasites, you know, vivax and falciparum, malaria came from completely different animal hosts in the distant past and in completely different epochs. But these started off like these, but for some reason they've taken off and become epidemics. So measles probably came from rinderpest. All these within the last 15,000 years or so, as Jared Diamond has argued in his book, Guns, Germs and Steel, some of which I agree with. Smallpox probably came from camels, influenza from birds or from pigs or recombinants of the two, recombinant viruses, and HIV and AIDS from chimpanzees and from monkeys, according to what strain. So they're new acquisitions, but they haven't gone away. And in evolutionary terms, we are a nouveau riche species for these infections. We're acquiring new ones, and HIV is really no different from others we've picked up in the past in that sense. Well, of course, we have had some real technological successes too. I didn't point out. We've eradicated smallpox as a naturally occurring spreading infection. Let's hope it doesn't come back by some more sinister route. We'll hear about that tomorrow. We've had a safe, efficacious vaccine against yellow fever for more than 60 years, live attenuated vaccine, similar for polio. And again, there's a bit of local trouble in the UK about the triple vaccine for mumps, measles and rubella, but it's of proven value. So there are ways to controlling these mass infections, and the main one is through vaccination. I think Paul Farmer already said that's one thing you can deliver even in impoverished settings if you get your organization right. So Darwin himself pointed out in his diary, The Voyage of the Beagle, that wherever the European has trod, death seems to pursue the Aboriginal. And we might well ask why. Here's the Aztecs' view of the conquest of New Spain, of Mexico. The Aztecs got a very bad press because the Spaniards won. And this shows measles. At first you get the high fever and thirst. Later you come out in spots, and then you die. And we know that the great city of Tenochtitlan, of modern Mexico City, was essentially conquered by 3 biological weapons: centaurs, that was Spaniards riding horses, which had never been seen before in the Americas, smallpox, and measles. And it was the little ones, the viruses, that really did the trick. Cortes was repelled from the city and had to retreat, but he left behind smallpox and measles. And then he came back in again because the Spaniards were miraculously immune. But they brought it there. This is the so-called Columbian exchange across the Atlantic. And over the ensuing century, these 2 viruses caused something of the order of a 95% reduction in the population of the indigenous population, the Native Americans living in modern-day Mexico, Guatemala, southern United States, as estimated, as far as one can estimate demography historically. These are figures taken from William McNeill. His book, published quarter of a century ago, Plagues and Peoples, is still well worth reading. Well, of course, not everything was a European export. The plague, as you know, came from outside Europe, from Central Asia. Interesting few changes in ecology there. It was endemic in burrowing rodents, marmots, and similar chipmunks in the Gobi Desert. But another species moved up from India, the black rat, was colonized by a new species of flea, Xenopsilla, and there was the fairly recently established caravan routes that Marco Polo had traveled along only a century before. He went this way and came back by sea 25 years later. And plague came to Europe through this little Genoese colony on the Crimea called Kaffa. So legend says the Genoese town was besieged by the Tartars, that we know for a fact, in 1346-47, and plague broke out amongst the Tartars. And so they took some of their bodies, put them on the catapults, and flung them over the walls into the city. Well, it might have just been that the rats got through the walls, we don't know. But the Genoese fled back to their ships and returned home to Genoa, docking in Messina, and plague was rife on the ships. The Messina authorities quite rightly quarantined the ships. They didn't allow anyone on and didn't allow anyone off. But the rats came down the ropes. Now, my first research was with plague rats in the south of India, and they can sure climb. They really do. They're very nimble little creatures. And the rest was history. And it's estimated, and we don't know the accurate figures, that across Western Europe as a whole, again, there was a death toll not half as bad as in Mexico, but of about a third the population. The Native American death following smallpox and measles was far worse. And we wouldn't have had the slave trade from Africa to the Americas if the indigenous people had died off, because you wouldn't have needed to import people. You had the conquered people there already. So AIDS is just the latest of some mass pandemic introductions into humans. Smallpox and measles, sometime we don't know exactly when. Typhus sometime later. The first authentic epidemic that we can ascribe to typhus, I think, is in Thucydides, the plague of Athens during the Persian War. Typhus always goes with war. The two most recent outbreaks in the 1990s, not surprisingly, were in Burundi amongst Rwandan refugees and in Bosnia. My father contracted typhus when he was in the German army in the First World War, was invalided out. But I'm glad he survived, or I wouldn't be here, I suppose. So what about the challenge of AIDS? Well, I think we can say that AIDS is a deadly terrorist, all right. I've already said it takes out young adults. Its daily toll across the world is roughly the equivalent of the collapse of 6 World Trade Centers every day. But because it's happening all over the world, and mainly in the third world, it doesn't have quite the impact. But demographically, that's what we are talking about, day in, day out. And you can see from these curves, you can't read the horizontal line, but it's 1982 to 2000 calendar years there. And this shows the annual increasing toll of AIDS in sub-Saharan Africa, the red line. And the blue line, or the black line it looks like down here, is the toll in the United States. This is not cumulative deaths, but annual deaths, just to show that the annual death rate has been increasing exponentially like that. And we've discussed this morning these inequalities in wealth and social systems. Why is it that it's done this in Africa and it's only done that in America? And in that sense, we could say AIDS is a disease in poverty. On the other hand, if this little blip wasn't there, we wouldn't have today's anti-HIV drugs, because that little blip actually in the United States, that's the same thing blown up. Paul Farmer's already shown a version of this curve. It came from nowhere in the United States and rose up to be the leading cause of death in people, men and women this is, of young adults again, ages between 25 and 45. And if we hadn't had the vociferous lobbying, first of the gay activists who were in the front line of HIV, I don't think we'd have had that impetus to develop what science we developed. Just to go back a moment, I got slightly agitated this morning in discussion about poverty and AIDS, because we tend to write off Africa as just one curve like that. If we look individually at what's happening in different parts of sub-Saharan Africa, there are enormous differences. AIDS was almost unknown before the late 1980s in South Africa, and yet South Africa now has more infected people than any other country, with the possible exception of India, because we don't know the real statistics for India. But if we look at the Congo, the HIV was in Kinshasa in 1976. Our earliest sample that's definitively positive for HIV. So there's a blood sample taken from Kinshasa, Leopoldville as it then was, in 1976. And when we first developed an HIV test that was robust and worked for sera taken from different peoples, different parts of the world, in 1984, we began looking in Africa, and we realized that slim disease, as it was called in Uganda, northern Tanzania, was really AIDS. We found that there were some 5% of the sample we took, just a few hundred sera, but enough to be representative, who were positive in Kinshasa. And Anne Bouvet and her colleagues at the Institute for Tropical Medicine, Antwerp, have been following up, looking at different cities in Africa. Now, in Kinshasa, with all its troubles, it's gone up from 5% to 8%. In Durban, in the same period, it's gone from 0, really 0, to about 34%. Why? Don't tell me that Kinshasa's wealthier than Durban. Utter rubbish. Why are there these discrepancies in Africa? And why are we northern sociologists talking about Africa and the developed world? Africa is a myriad of different local epidemics. And Anne Bouvet, she studied 4 cities in particular, Kisumu, Kinshasa, Yaoundé, and Lusaka. Totally different dynamics to the HIV spread in these 4 cities. So I think we've been too simplistic thus far in this meeting. I'm not an epidemiologist, I'm not a sociologist. I'm just looking at the actual facts of who is positive for HIV and who isn't. And I say what we've discussed to date doesn't quite add up, that it's much, much more complex. And that's why it's difficult to control. Now, let's also acknowledge, as Paul Farmer did, some successes. He pointed out this remarkable fall in mortality due to HIV and AIDS in the United States since about 1996. Now, this isn't because HIV has stopped spreading in the United States. And anyway, deaths from AIDS reflect what was spread 10 years earlier. That was the introduction of combination drug therapy, drugs that prevent HIV replicating. It took a little time for the virologists to realize what the TB people and all cancer doctors knew already, that if you treat with more than one drug, you've got a chance of having an effect. And these have been remarkably effective and have cut down the mortality by about 2/3. But of course, there is a substantial number of non-responders. There's a substantial amount of transmission today of multiply resistant, or it's becoming multiply resistant, HIV. So we've got the same sort of problems as TB. And we don't know how long the treated people who are not cured of HIV infection, but just have their viral load knocked down, how long they're going to survive, whether this is going to creep up again or whether it's going to stay down. But it's a remarkable achievement, and it's an achievement of molecular biology. This is rational drug design. The virus was isolated just 2 years ago. 1981 was the first recognition of AIDS. By 1983, Françoise Barry-Senussi and her colleagues in the Institut Pasteur had isolated the virus. By early 1984, we knew it was the real culprit, and began to study it. And what Barry-Senussi and her colleagues had already shown in May 1983 was that this was a retrovirus, and that therefore it had certain unique properties that were open for attack. Retroviruses replicate by reverse transcription. So inhibitors of reverse transcription turned into drugs and have worked. The first trial of zidovudine, as it's now called, worked temporarily, but it was soon seen that their resistance arose. The next drug, nevirapine, resistance came up even sooner. Within a month on treatment, a patient would become resistant. So it was decided that it wasn't a good drug at all. But in fact, as we shall see, it turns out to be an extremely effective drug for special occasions, like mother-to-child transmission, where the question of resistance doesn't come up. Then later, the protease inhibitors, once the virus, it makes its DNA, the DNA integrates, so integration is a very promising target for drug development. But when it replicates, the new RNA genomes have to complex with the new core proteins of the virus into the next generation of viruses. And these won't become infectious unless polyproteins are cleaved by the virus's own protease into their component parts so that the conformational changes take place to give you an infectious particle. Pure molecular biology. Inhibitors of those proteases are preventing people dying. So rational drug design has really played its role based on the study of the molecular biology of this virus. And there's now a lot of interest in where my research is centered on how virus gets into cells, binding to CD4, fusing with chemokine receptors, and seeing if one can block that stage. So science has really helped. But as we've already heard this morning, it doesn't always percolate well. And when you're sitting in some settings faced with this threatening, ununderstandable epidemic, when you kind of know that it's spread by sex and spread by blood, sort of not very nice things to talk about, that you look for other explanations. So there's denial. Well, a lot of the world is just sweeping AIDS under the carpet. But there's the, so to speak, informed denial. So on President Mbekki's panel, there was Professor Stewart from Glasgow, emeritus epidemiologist, declaring AIDS is not an infectious disease. It's not transmissible, period. Then there was Val Turner from Perth in Australia. HIV does not exist. It has never been isolated. Advisor to President Mbekki. And then there was Peter Duesberg said, of course HIV exists. You're quite wrong, Dr. Turner, but it's harmless. So these are the so-called dissidents. They're not exactly assonant between themselves. But they've had their influence. Then the Hope and Fassin, Didier Fassin has already commented on that. And then there's blame. Even when you agree that HIV causes AIDS, when you're helpless confronting this new pandemic, what do? You've got to blame someone. And again, speakers this morning have talked about this widespread belief that HIV is a deliberate export from America. There's been a long debate. HIV can be blamed on the polio vaccine, an unwitting, undeliberate contamination polio vaccine. Both of them quite wrong. But let's not be too smug about laying the blame. In 1349, when the plague finally came up the Rhine and reached Mannheim, very important centre where the Neckar flows into the Rhine, there was great fear further upriver in Strasbourg, and the good burghers of Strasbourg blamed the Jews, not for the first time and not for the last time. And so before plague arrived, they burnt 900 Jews. To his credit, Pope Clement VI, at the time, holed up in Avignon, in exile from Rome, observed that plague afflicts Jews as well as Christians, and they are not to blame, which is one better than Pope Pius XII. So Clement VI promoted the flagellants, and they became so popular he later tried to suppress them. And these were the people who went around with whips and would whip themselves until they draw blood as redemption in the hope of preventing plague. And the last great plague epidemic in London was in 1665, and the Reverend Solomon Eagles also made the observation that plague is the Lord's retribution for our sinful ways. That fitted the plague epidemic in that you didn't know who was going to get it next. Our modern day religious fundamentalists, like the Reverend Pat Robertson, who advises important people in the American government, has actually puts the blame on specific groups. AIDS brings just desserts. Sorry, mate, it's your fault because you're living immorally, which again shows a certain understanding of the nature of HIV in contrast to plague. And then there are what I would call the eco-fascists, the more extreme amongst the Greens. You see, AIDS is a godsend for the Earth's human infestation, that it's our only solution to the overpopulation problem. And I'm glad the New Scientist came up with a riposte to that, the little cartoon saying if Gaia sent AIDS, she wouldn't have invented rubber trees. So, so where did AIDS come from? Well, like all those other pandemics, it came from outside mankind. And I think Pliny the Elder was right with his out of Africa theory. He said something new is always coming out of Africa. We've had out of Africa theories ever since. A great scientist, Pliny, unfortunately died going up Mount Vesuvius to observe its eruption in AD 79, but in the course of scientific duty. We actually have two main types of HIV, HIV-1 and HIV-2, and they come from two completely different animal species. HIV-1 from Pan troglodytes, the chimpanzee, a great ape, and HIV-2 from a monkey, the sooty mangabe, lives in West Africa. With HIV-1, there have been at least 3 separate transfers from chimpanzees, so far as we can tell, because the genetic diversity, again, molecular biology, sequencing the genome, indicates that the 3 main groups of HIV, M, N, and O, are as different from each other in their genetic diversity as any one of them is from the chimpanzee isolates. So it looks as if this has happened 3 times. And it's only group M that has grown to become a worldwide pandemic, whereas group N and group O have largely stayed in West Central Africa, even though in 1976 a Westerner was infected with group O, Scandinavian, and imported back to Europe. But they haven't spread. Why has group M spread and not the others? We don't quite know. And to what extent were these transfers and the onward spread natural or artificial? Well, I don't believe the polio theory, but I do think once probably a natural accidental spread from animal to human taking place, that we might have had some kind of iatrogenic spread in terms of helping HIV adapt itself to the new human host before it became efficient at sexual transmission. And that is dirty needles and hypodermic syringes. Here's a study by Ernest Drucker, Preston Marks and others. This is a scale of the last century, 1900 to 2000, of the falling unit price of hypodermic syringes and needles and the global production. From the times when each one was handmade and had to be put together and was reused hundreds of times, and until plastic ones came in and so on. And it was during this period in the mid-century, we could say, that they became widely available in developing countries as well as developed countries, but they were still expensive enough to recycle them. And I think we can attribute the worldwide pandemic of AIDS partly to that, and of hepatitis C, and to quite a significant extent hepatitis B. And even today, with this low unit price, here's a couple of lads on a rubbish tip near the Tata Memorial Hospital in Bombay. And what are they doing? They're picking up the used needles. And they've got a sale value to those kids. So you can imagine what would happen. So what can we do to prevent HIV? Well, we could stop having sex. That's not easy. So we've got various things towards sexual health, of which the most practical might be to try and keep other sexually transmitted infections down, because they probably exacerbate the probability of transmission. Paul Farmer didn't like condoms, or at least said they were too gender specific. But who are the students in the audience? Let's have a show of hands. There must be some here. Well, students living in a Western country, I can only give one health message. So, so here you are. Strawberry flavored. Banana flavored. Have a few more. Have a condom. Have a condom. If anyone wants to see me afterwards, there's a few more. So they're not the whole answer, but they're part of the answer. The molecular biologists amongst you will recognize this. It's a space-filling model. It's a heterodimer. N-terminal globular domain. The active site is behind the beta sheets. Again, we have had some real successes in the AIDS pandemic. Just think of it. HIV was first isolated in 1983 in Paris. By the fall of 1985, we had almost universal screening of blood donations in the developed world. Now, that is fantastic progress. Within 2 years of the first tentative, this may be the virus, we knew how to screen for it, how to recognize it, develop that into mass screening, and effectively hemophiliacs and recipients of blood donations have been protected ever since. So let's not belittle the success we've made. And again, there were social reasons why clean needle exchange took much longer. Amsterdam had it by 1986, but to persuade the British government or the moralistic US government that taking in a dirty needle and giving a clean one in exchange was a good thing took a tremendous effort, because it was perceived as handing out needles to junkies, which wasn't quite the thing. And then there's the mother to child. I'll come to that in a moment. Now, this is the naughty one. Now, some years ago in Bombay, I bought a T-shirt that had that message on it. Now, I think that's a wonderful sexual health message. The pictures are mine. I show them to students when I lecture on STIs and explain that these are from Khajuraho, and they were carved 1,000 years ago, more than 1,000 years ago. They say, gee, were they really doing that 1,000 years ago? No. But anyway, there's lots of different ways to have fun, but try and do it with only one person. And I don't want to be just Indian, so these two are African. And this is 18th century Asante gold weight for, as a measure of weight. It still shows the same thing. And there's mother-to-child transmission. We've mentioned nevirapine, which is no good for treating patients who are already infected as a monotherapy because you develop resistance so fast. It's a wonderful way of a one-hit reduction in viral load. So someone who's infected, give them one shot of nevirapine, and you get something like a 3 to 4 log reduction in virus load. Virus load is what matters with perinatal transmission. So one dose to the mother, a small dose to the child, and you can cut out a large proportion of perinatal transmission. But then you've got a problem. What about milk transmission? The mother's still affected. So we know what to advise people in the developed world. Formula feed. But is that right in every setting? If you don't have clean water, well, Nestle's will say it's right because they're trying to sell formula feed right across Africa. But it's not necessarily the case. So we have, we solve one problem and we create new dilemmas. Well, last year, UNAIDS estimated just the new infections last year were something of this order, and these are probably great underestimates for Eastern Europe and for the Far East, countries like China, where we think there's far more infection going on than we really know about. And probably, according to UNAIDS, the fastest growing rate of infection was in Eastern Europe, not in Africa. And by and large, until recently, many of the governments in Asia had this attitude. Just hear no evil, see no evil, speak no evil, sweep it under the carpet. We're just beginning to get to the stage when they're promulgating health messages such as spread no evil. We'll hear more from Yi-Ming Shao, I hope, later in the meeting. But what are we really going to do to lick this problem of AIDS? We need a vaccine. Now, I'm one of those pessimists at the moment, like Samuel Beckett. We don't have a vaccine yet. We've got to go on trying. We've got to go on failing better. This is rather different from John Cohen's view. He's a journalist who writes excellent copy on AIDS in Science and published this book last year where he really said, well, we could have an AIDS vaccine, if only we got our act together. That it's an organizational problem more than it's a scientific problem. But I'm afraid I think it's still a scientific problem. I think we haven't discovered what immunogens they are that are protective against AIDS. And one of the answers to that, I mean, not a solution, but reason why, again, comes out of molecular biology. These are some data from Betty Corbin, Los Alamos Laboratory. And this shows the genetic diversity of the strain of global influenza A that was prevalent during 1996. The longer the spokes are, the more diverse it is. This, on the same scale, shows the genetic diversity of HIV in a single individual 6 years after infection. So the number of variants in one human 6 years after being infected with HIV is roughly the same as the diversity of influenza, another RNA virus that has no editing mechanism for replicative mistakes. But that's absolutely remarkable. And if we look at the Democratic Republic of the Congo, where AIDS first started spreading, here we can see these enormous spokes. These are all the different clades of HIV-1 group M. So we've got this genetic diversity, and it doesn't help us. It's not like polio, where we can just have 3 strains, a vaccine that combines the 3, and it works. Nonetheless, there are international vaccine trials going on, and some of those scare me too. The VaxGen trial that's passed ethical review, despite everything that was said about ethicists this morning, by the WHO, by EVARVI, by the Thai government, nonetheless, I would say might be more harmful than it is protective. Because no one on any of those ethical committees once raised the question of immunization that can make you more susceptible to infection or disease. And I'll give just one real example of that, and that's dengue fever. If you're infected with one strain, when you meet a new strain, you're likely to get a far worse disease. And the reason is simple. Both dengue and HIV will replicate in macrophages. If you have antibodies, if you've got enough of them, and they have a high enough affinity, they'll neutralize the virus. Lower the affinity or lower the titer, and they may simply act as bridges to draw the virus to Fc receptors, I'm speaking molecular biology again, on macrophages, and instead of being phagocytosed, they infect the cells, and then you've got infection. Now, I'm told by VaxGen that this hasn't happened, but what is the period of follow-up? It's a period of follow-up is when you expect to have high titer antibodies, and they will stop following up in a couple of years' time, and that's when the danger will start. So I think we need a Hippocratic oath, not only between a physician and his individual patient, but a Hippocratic oath for epidemiology, that you don't try things out on society quite before knowing what's going to happen. But last time I raised this at the Institut Pasteur at a meeting on vaccines, I was shouted down by the Thais and others saying, we haven't got anything, we've got to try something. Something must be done about AIDS. Let's hope it isn't harmful. Okay. So, to summarize, I think today's epidemics were yesterday's curiosities. Tomorrow's epidemics may come from today's lifestyles, not just sex. And we virologists tend to study viruses. People at EMBL focus down even further. This is the molecular structure of reverse transcriptase on its substrate and product. But we're also at this meeting standing back. And while this is a 100 nanometer view, this is a 1,000 kilometer view, this is a satellite picture of India, as it happens. And this is where I'm concerned about the megalopolis, and also this point. Look to the future a bit. What is AIDS going to do for other human infections? We're going to hear about tuberculosis. But just take that one genus, Mycobacterium. AIDS patients not only get TB, they get infections, severe killing infections, by other species of Mycobacterium that most of us have never even heard of. MAI, Xenopi, Kansasi, Fortuitum. And these are all zoonoses, or things that come from the environment, that are one-off in the AIDS patient. Now, take a city like Mumbai, has a population of 17 or 18 million. Wait 5 years when the prevalence of infection may be as high as in Durban, when, say, 30% of the population is infected, maybe 10% of the population will be immunocompromised. This is an almost unique situation in vertebrate evolution. Ever since the immune system evolved to have lymphocytes, we have not had populations that have had a significant proportion so immunocompromised as we're beginning to see in the world's megalopolises due to AIDS. And who knows what impact this may have, not on HIV itself, but on lots of other microorganisms that may be rare occasional zoonoses today, but may become mankind's next infectious diseases. We were asked to look in the future as well. I'd like to say, if you want to see some of these ideas written down, I did publish an article in Nature last year in the name of Gulliver. But there's a health warning that comes with this article, that everything I've said is unsure prediction. Some of you will think it's idle speculation, and others may consider it even as wild conjecture. But that's one of the things we're here to do. And lastly, I'd say that none of this is particularly original. 300 years before Pasteur and Koch nailed down the germ theory of disease, this is what Fracastoro had to say when he wrote his great treatise on syphilis. Thank you. I'm sorry, I took too long.